Hello everyone, we already know each other. I am Angel and I work as a data engineer at Analytics Power. Today we are going to talk about improving performance and reducing costs when running data transformations on Spark. Imagine you are processing data. There is a query reading multiple large tables from storage with a long list of complex transformations. Because of the lazy evaluation principle, Spark is going to execute all these transformations as soon as there is an action invoked. Let's see how this works in practice. To visualize this, we will be using a representation of the logical execution plan, the DUG. Spark creates the DUG of the data process, and as soon as it runs into an action, it starts executing it. In this case, we have three tables used as inputs. We are joining them and performing complex aggregations. The resulting data frame is written to storage. This process requires some capacity and time to be executed because of the amount of data and the type of aggregations. Next, we have another table we need to create. The inputs are similar to the previous case, with the addition of another source table. We start by joining the three tables and performing the same aggregations. In the next step, we are joining additional data frame to this aggregated data frame. The result is written to storage. Looking at both DUGs, we see there are some similarities. The joining of the first three tables loaded and the subsequent aggregation are performed twice. As previously mentioned, these are large tables with complex aggregation operations performed. This means we are performing the same costly operation twice. So how could this process be more cost and time efficient? We know that the second join is performed on the aggregated table. So we could keep the aggregated table in memory, execute the first write, and continue with the second join and writing. This means the join of the three large tables and the complex aggregation is performed only once. The command to keep a data frame in memory can be seen here. Cache is a lazy operation, meaning the table would be cached during the first write action. When the second write action is triggered, the executor finds the data frame in memory and uses it, instead of computing it again. We need to be careful with caching data in memory. This will occupy the capacity and would consequently affect performance. Whenever we are done with processing the cached data frame, we can simply remove it from memory. To sum up, the problems with repeating transformations are more visible when working with larger quantities of data and more complex and longer logical execution plans, including multiple actions. It could significantly affect the performance of the Spark process. It could increase costs and processing time and even lead to unsuccessful executions. Therefore, using caching is a good practice to ensure smoother, faster, and cheaper executions of our Spark data transformations.